Now, I heard this in a video once, but I'm not sure. And it's the answer to the possible question of why would they pour sugar into a lake? Like the only thing that I think I can recall is them saying to like reduce methane. Other than that, I don't know. But your boy is intrigued. Let's check it out.
In 2018, a group of scientists got into a motorboat on a lake in northwestern Ontario to do something that had never been done before: deliberately pour almost 90 gallons of oil into the water. Over the next 2 hours, the team of ecologists and chemists carefully pumped the thick liquid into a series of isolated areas in the lake. But as strange as it may sound, this isn't a group of mad evil geniuses, and everything that happened didn't lead to a scandal. Quite the opposite. In fact, scientists here are always doing something unusual, and not only are they not stopped, but they're even helped. For example, one time scientists dumped several tons of sugar into the lake to, well, let's take it one step at a time. But first, a little coffee.
But even if you're dumping oil in a controlled area of the lake, isn't that still harming the lake though? I would like to think so. There's no possible way you can remove all of that oil that you dumped into the lake, even if it's in a controlled area, out. Does that controlled area stay there for the lake's entirety? Because if you remove these barriers, some form of that oil is still in the lake, I would like to think. I don't know. Just, I got questions.
Just an unobtrusive reminder to hit the like button if for some reason you forget to do so at the end of the video. Let's start perhaps with the oil. You might have already guessed why they might pour it into the lake for scientific purposes: to simulate accidental oil spills and study them. Because when oil spills happen due to some kind of accident, there's usually no time for research. The priority is to quickly save the area that's under threat. And it was to understand how oil works and what to do with it that these studies were carried out. For 3 summers, scientists studied intentional spills to learn more about how oil affects lakes and boreal forests, the type of landscape that stretches across northern Canada, Russia, and Alaska. This project's considered one of the first of its kind, as most oil spill research is done in laboratory conditions, well, or at the sites of accidental spills. But as I've mentioned, that's not always convenient. In fact, both options fall short compared to lake research. Lab experiments can only simulate simplified versions of complex ecosystems, and when disasters occur, the main focus is on cleaning up the oil as quickly as possible, not gathering scientific data. There's also often a lack of basic information at sites of accidental spills. Scientists compare this to arriving at an accident site with no prior knowledge. In other words, you don't know what exactly happened, how it happened, or what the situation was like before the accident, and that makes it much harder to assess the aftermath. Now, controlled spills in clearly defined areas are a whole different story. By carefully monitoring them, researchers hope to gain insights into the impact of oil on the environment under real conditions. In the future, this could help policymakers and the oil industry develop more effective ways to manage spills, while also providing scientists with the necessary information for further research. And although deliberately polluting a lake might seem like a pretty strange way to protect the environment,
Thank you. You're still destroying this lake to get your results. I get the whole greater picture thing, but at the end of the day, one lake has to be destroyed for the rest to survive is ultimately what you're saying, though, right? Right. It has to be.
that's exactly what they're doing in the IISD experimental lakes area. This unique research station, known internationally, consists of 58 small bodies of water within a 75 square mile stretch of boreal forest. For over 50 years, researchers have been using these lakes as real outdoor laboratories. Over the past 50 years, they've poured all sorts of pollutants into these waters, including fertilizers, mercury, sulfuric acid, estrogen, and it's been for good reason. Because monitoring how these substances affect ecosystems, and often entire lakes, has played a crucial role in freshwater research and policy making. What's more, such research has actually led to a dramatic improvement in water quality worldwide. After all, it's the only place in the world where scientists have entire lakes at their disposal, which they can manipulate and observe to see how pollution impacts the environment. And often this can be observed over decades. So it's clear why this place is called the Super Collider of Ecology. But let's get back to the oil and how it ends up in water. As I mentioned, in the summer of 2018, a group of researchers added oil to 8 different sections across the lake, simulating real spills, from small incidents to the 2010 Kalamazoo River spill. Just so you know, that was one of the largest freshwater spills in U.S. history. The team studied how the oil moved through the water and impacted organisms, including insects, fish, and amphibians. Then, in the summer of 2019, scientists created a fresh set of spills in 18 enclosures along the shoreline. After discharging the oil, they removed much of it using common cleaning methods, such as absorbing the oil with absorbent materials or spraying the shoreline with low-pressure water hoses. However, these methods don't guarantee 100% cleanup. Sediment always remains on the shore and on plants. This is exactly the problem the researchers were working on. They were looking for the best ways to absorb the remaining oil. They tested various cleaning methods, including shoreline cleaners, natural bacteria, and floating wetland treatment systems, islands made of local plants that proved effective in tests conducted in India and Pakistan. And here's a question that popped into my mind. How did all these even begin? I mean, at some point, someone must have had the idea, hey, let's just pick a couple lakes, pour all sorts of stuff into them, and then see what happens. I decided to dig into the history, and here's what I managed to find out. When this research center first opened in 1968, the biggest concern for ecologists was the algal blooms in Lake Erie. These were caused by pollution in the water, which led to a lack of oxygen, ultimately resulting in fish kills. This phenomenon is called eutrophication, a big word describing a major problem that many estuaries or river mouths face. Eutrophication happens when the environment becomes too enriched with nutrients, leading to an increase in plants and algae in estuaries. And it's a really common problem. 65% of estuaries and coastal waters in the U.S. that have been studied by researchers have moderately or severely degraded due to excessive nutrient input. This inevitably leads to an increase in oxygen levels.
I know y'all have seen lakes that look exactly like this where you live, if you live near any lakes or anything like that. I know growing up, I could think of several off the top of my head that I would drive past, maybe on the way home or every day on the way to school or something like that, or in certain neighborhoods you'd be out and you would see lakes that look just like this, but I never thought that that's what was going on. And I never thought the fish were suffering. I just thought this was just part of, you know what I mean? Just part of the ecosystem. This is just what happens, right? And we had a lake in where my grandmother lived, near where she lived, right? And they had, and this is why this makes me nervous as well, because they traumatized me as a young kid, and I still don't know if it was true or not. But they had told me that a septic tank had kind of backed into the lake, and it kind of just destroyed the lake. So seeing green like this also makes me go back there in my mind and think about those stories. It probably was just stories they was telling me as a kid, but it stuck with me. So when I see green like this, I think algae, I think different things, but I also think about that.
Causing a chain reaction that results in the death of all living things. At the time the research center opened, eutrophication was poorly understood. A chemical stew of pollutants was being dumped into Lake Erie from farms, cities, and industrial areas, and the researchers had no idea which specific pollutant was responsible for the algal blooms. So 2 scientists, Wally Johnson and Jack Valentine, were tasked with finding the root of the eutrophication problem. After some thought, they decided that experiments in a lake could provide answers that couldn't be obtained in lab conditions. The search for a suitable location began. They needed an uninhabited area with minimal human impact, no resorts, no agriculture, and limited deforestation. In the end, they chose a location about 2 hours' drive from Kenora, Ontario, a city on the...
And y'all wonder why the planet is mad at us. Y'all wonder why different things happen. It's because we're doing stuff like this in the background. We're doing things like this to destroy it, essentially, because although it may seem like a small, concentrated area that they're doing this in, but let's just say they decided to do it there. Some scientists in another location decided to do it there, and so on and so forth in other areas, and they continue to try. That stuff adds up. You wonder why it's responding the way it is. We got to stop doing this to it.
western edge of the province. The area was perfect, with thousands of small, untouched lakes nestled in rocky terrain and surrounded by dense spruce and pine forests. To this day, there's only one gravel road leading to the area, and you can't drive on it without special permission. Each lake here is numbered, so it's pretty serious. Anyway, in the late 1960s, experiments began here to test eutrophication. Phosphorus was chosen as the first pollutant. A group of scientists stretched a plastic curtain across the middle of Lake 226, then poured carbon and nitrogen on both sides of the lake, but added phosphorus only to one side. Soon, the phosphorus-polluted side was covered in clouds of algae. An aerial photo of the experiment became famous. And by the way, it had an impact on the entire detergent industry. The thing is, phosphorus was actively added to detergents all over the world, especially in the 1970s. Not without reason, this ingredient increased the effectiveness of the products, but it had a major drawback. Phosphorus would remain in wastewater and eventually end up in natural water bodies. The problem isn't just about getting it into the water. Phosphorus itself is low in toxicity, but once it's, let's say, set loose, it causes nutrient pollution. In other words, it triggers eutrophication. Today, both scientists and manufacturers know about this, but before the 1970s, no one even considered that phosphorus could behave this way. And it was right here at the experimental lakes in Ontario that this was figured out. The image created here convinced politicians that phosphorus should be regulated. In the 1970s, the governments of Canada and the US passed laws banning phosphates in detergents, but the experiments didn't end there. If you look at the related documents, you'll find that sucrose was used as the carbon source in the lakes. Manitoba Sugar's brand of sucrose was delivered in 24-pound bags. In fact, there were many phosphorus experiments conducted at the lakes, and they went on for years. The scientists not only wanted to understand if phosphorus was truly responsible for eutrophication problems, but also to find out if sugar, when enough phosphorus is present, could limit the growth of unwanted algae. In other words, could it act as an antidote? And if this is possible, is there a chance of restoring lakes that have already undergone eutrophication? So in 1971 and 1972, phosphorus, nitrogen, and sugar were added to a separate lake. As with other experimental lakes, the addition of fertilizers triggered an algae bloom. Then in 1973, the scientists continued adding nitrogen and sugar, but stopped adding phosphorus. They wanted to simulate conditions that could exist in a body of water after phosphorus control measures were implemented. Wastewater still flows in, but it's no longer contaminated with phosphorus, and unexpectedly, this led to the complete recovery of the lake. The scientists concluded eutrophication in lakes can be reversed simply by reducing phosphorus input. This leads to a proportional decrease in phytoplankton blooms and other bloom symptoms, and that's it, everyone's happy, especially the fish. But wait, what does sugar have to do with it? Well, I have a theory. The experiment was conducted in pristine lakes, but the scientists needed water similar to real wastewater. Of course, no one was about to transport actual sewage water to who knows where, so they decided to recreate it. And sugar's an important component of urban wastewater. Long story short, without sugar, the experiment wouldn't have been accurate. Since then, researchers have used the experimental lakes area for various high-efficiency experiments. For example, from 1976 to 1993, scientists added sulfuric acid to Lake 223 every week, simulating acid rain and gradually lowering the lake's pH from 6.8 to 5.2. The resulting shift in the ecosystem and the loss of several fish and invertebrate species demonstrated just how sensitive the aquatic food chain is to acid rain. While this might seem obvious to us now, we learned all of this thanks to these experiments. Among the numerous effects discovered as a result.
That makes me scared because weather modification. We don't know what they're putting in the clouds during cloud seeding and what's coming down in the rain. I always say, man, rain makes me nervous nowadays because I don't know what's in it. And it could have several different chemicals in it. So now seeing that animation of the fish dying as they were simulating the acid rain makes me nervous. One, for the fish as a source of food for us, and two, that as a source of food, what are we eating? What are these fish swimming in, absorbing, eating, everything that contains whatever is coming out of the clouds? They wonder where all these different sicknesses and different things we encounter and come up with and are different things that are happening to our bodies and these new. This is why it's a direct result of that. Like, man, if you don't see where we're headed now, we're headed down a dark road. And it's our own that are doing it to us. It's man that is doing it to us.
Result were the deterioration of fish body condition and serious reproductive issues in white suckers and lake trout, as well as the near complete disappearance of fathead minnows. In nature, acid rain forms when nitrogen oxide or sulfur dioxide gases are released into the atmosphere, primarily as a result of fossil fuel burning. In other words, it's a pretty common situation. These gases react with oxygen and water in the clouds, forming nitric and sulfuric acid, which can then be carried over long distances in clouds before falling to the surface as precipitation. But don't think of acid rain as literally being acid like sulfuric acid that melts everything in its path. In reality, it's just a liquid with high acidity. However, decades of such acidic precipitation falling on landscapes gradually acidify soils and lower the pH of lakes around the world. In short, the research was important and necessary. It played a significant role in changing air emission regulations in Canada and the United States. Based on the evidence provided by this and other studies conducted in the 1970s and 1980s, legislation was passed aimed at reducing industrial emissions. These measures led to a significant decrease in nitrogen oxide and sulfur dioxide emissions in the following decades. And what about Lake 223? It continues to be monitored even decades after the official end of the acid rain experiment. Unfortunately, the results of these observations aren't very positive. Even though the chemical composition of the water has returned to pre-experiment conditions, the lake's biology is never fully recovered. Another interesting experiment.
Exactly. And we don't believe it's returned to anything. You can never fully get it back to normal after you do all of those different experiences. You can't convince me otherwise. No way.
It's related to Lake 658, a small lake that helped us understand how mercury circulates in the environment. From 1999 to 2007, another group of scientists added mercury to the lake's water, demonstrating how the heavy metal released by coal-fired power plants affects food chains. This groundbreaking research played an important role in our understanding of the mercury cycle in aquatic ecosystems and once again influenced air emission policies across North America. Mercury is released into the environment from many natural and artificial sources. For example, a coal power plant can emit mercury into the air in the form of vapor. Mercury can also travel long distances through the atmosphere, even across oceans and continents, before finally settling in lakes and rivers. In other words,
isn't the EPA supposed to regulate this type of stuff and make sure this is not happening? Shouldn't businesses and different things be fined or shut down if they do break the law and violate these EPA regulations? Shouldn't they? You would think so, but it ain't happening.
In other words, it's a problem without borders, and mercury released by a power plant in Asia can end up in a lake in America, and vice versa. There's also something called methylmercury. This is an organic form of mercury that forms from inorganic mercury through the action of microbes living in aquatic systems. Methylmercury then enters fish, including those that people eat. You see the problem? Fish is an important source of protein for people. Many people around the world rely on it. And through fish, methylmercury enters the human body, where it can accumulate and cause serious health issues. And perhaps most of humanity would have been seriously poisoned by mercury if it weren't for the lake studies. Partly because of them, the Minamata Convention on Mercury was adopted, an international treaty aimed at protecting people from mercury poisoning.
We're still dealing with that, though. How many times y'all hear that? Don't eat large amounts of, tuna or other different fish and stuff that you may like, because it possibly has so much mercury in it. Like, we're still dealing with that. So yeah, they discovered it or figured it out maybe, but it ain't like it's been eradicated. No, we're still dealing with that to this day.
Again, by reducing its emissions into the environment. But perhaps the strangest experiment was conducted when scientists began pouring estrogen into the lake. To put it simply, estrogens are female sex hormones. It turns out these hormones have a negative effect on fish, causing sexual development disorders. And we know this partly thanks to the experiments in Lake 260. Starting in 2001, synthetic estrogen EE2, which is commonly found in birth control pills, was added to the surface waters of Lake 260 to study its effects on the overall health of the lake. The results of the study were widely cited by regulatory bodies in the European Union. There, EE2 is referred to as a chemical of concern. Concern was also raised by British Columbia. But what's the reason, really? The answer's simple. A hormone that enters wastewater from the urine of people taking birth control pills causes male fish to develop female traits, which eventually leads to a decline in their population. The males start producing eggs, their behavior changes, and eventually reproduction completely stops. Moreover, the fish couldn't reproduce for almost 5 years after the estrogen was added to the lake. By the way, they were also dumping oil into this same Lake 260. Poor fish. By the way, what do ecologists and animal rights activists think about this? Experiments like this one and others conducted in lakes spark surprisingly little controversy. People usually don't get upset, even though scientists are completely open about what they're doing. For example, most of the information I used in today's video came from the official project website. That is, the researchers really share a lot about their work. They also hold informational sessions with various communities living near the research area and post updates on social media. Also, the scientists emphasize that they don't dump chemicals into lakes on their own accord. Before starting the experiments, they must prove to regulatory bodies that their actions won't have a toxic effect on people and won't affect downstream waters. And they're required to restore the lakes to their natural state within 10 years. In total, the research station has published 745 peer-reviewed scientific papers, 126 theses, 102 book chapters, 185 data reports, and several full-length books. Scientists working at the station have received numerous prestigious international awards in the field of water resources. Overall, they're more supported than criticized. Today, the site continues to conduct experiments, adding research on nanosilver, microplastics, climate change, and much more. So in 2014, nanosilver particles were added to Lake 222 to study the impact of this pollutant on freshwater ecosystems. Over a 2-year research period, scientists found that phytoplankton communities, for the most part, couldn't care less about nanosilver. However, yellow perch and northern pike, as it turns out, can accumulate nanosilver in their tissues, especially in the liver. This bioaccumulation could pose a threat to aquatic food chains. Besides silver, antidepressants were also added to the lakes. And no, not to cheer up the fish after all these experiments. It's well known that biologically active forms of ingredients found in common antidepressants make their way back into freshwater systems. In general, this happens in much the same way as estrogen. However, little is known about their impact on aquatic ecosystems. In 2021, venlafaxine was introduced into boreal lakes at concentrations previously detected in other freshwater bodies. The goal of the study is simple: to determine how antidepressants affect lake inhabitants, their behavior, and the ecosystem as a whole.
Listen, they ain't gonna be happy. I think I've seen this in a movie somewhere or something. Like, they ain't gonna be happy till they pour something in a lake, and now this new species of fish is created. One that operates in water and in land, and it's very dangerous. It's gonna be on some Jurassic Park type stuff. Watch what I tell you, man. Give it about 5 to 10, maybe 10 to 20 years, and they gonna mess around and stumble upon something that's gonna wipe us out.
But since this happened quite recently, the results are yet to be determined. By the way, in one of the latest studies, Tom Bean from the University of York and his colleagues found that the common antidepressant fluoxetine, even at low concentrations, made starlings feed less frequently during key foraging times at sunrise and sunset. And these were exactly the concentrations starlings might encounter in the environment. This has nothing to do with our lakes, but it's yet another example of how such substances can affect living organisms. Well, aside from humans, our case is pretty clear. As for the lakes, one of the most recent experiments took place in 2023. That year, chemicals used to protect tires were added to Lake 302. Specifically, we're talking about 6-ppd quinone, a substance that shields tires from degradation caused by ozone and UV radiation. However, sooner or later, tire surfaces wear down and the compound ends up in the environment through stormwater runoff. Researchers introduced different levels of 6-ppd quinone into Lake 302 and then monitored various aspects of the water column, from water chemistry to fish and insect populations. And it seems they've managed to link 6-ppd quinone to the mass die-offs of coho salmon along the U.S. West Coast. But the study's still ongoing. We'll probably have to wait a couple more years for the final results. The biggest news in the past few days is that I stepped outside, and it was pouring rain. Yep, it's winter out here with snowbanks everywhere, and, well, a downpour too. Disinfecting the lake. Today we talked about all sorts of substances being added to lakes, but it seems I forgot to mention disinfectants. Yep, they're being tested too. Why not, right? This time they chose Lake 375, where researchers decided to introduce quaternary ammonium compounds, or QACs for short. These are synthetic cationic surfactants that contain a quaternary ammonium ion. To make it easy.
Now, what about the birds and stuff? What about the birds or different things like ducks that swim into the lake? Maybe when they're not around and the ducks get into it, whether they get into the oil or the sugar or the chemicals and carry the chemicals somewhere else. A duck can completely ingest or do something, carry it on to another lake and affect that lake. And you see what I'm saying? Like, what about that? That's the part of nature and life that we don't equate in. It's always a variable unknown that you didn't account for. What about that? And don't get me wrong, I appreciate and get all of the research results that have came from this. It's probably been groundbreaking. It helped us tremendously. But you just can't forget about the other side. That's all I'm saying.
Easier to understand, we use them every day. They're in hand sanitizers, cleaning sprays, surface wipes, and pretty much any product that boasts kills 99.9% of germs. Yes, this substance is widely used, but we know little about its impact on fresh water and the organisms living there. While we understand that the chemical composition of these compounds makes them great disinfectants, we still don't fully grasp the extent of the harm they cause to algae, bottom-dwelling invertebrates, fish, and even mammals. The experiment's planned for 4 years and is still ongoing. After it's concluded, our perspective on disinfectants might shift. New regulations could be introduced to control their disposal. We just have to wait a bit longer. Superdogs. Great news for humanity. A group of scientists from the International Institute for Sustainable Development announced that, thanks to their recent discovery, fighting oil spills and protecting fresh water in Ontario will become much easier. But what is this discovery? The answer is simple yet fascinating. Dogs. According to the research team, specially trained service dogs were able to accurately pinpoint the location of 2 types of oil beneath the ice of a lake in 6 out of 6 cases. In other words, the dogs demonstrated a 100% success rate. The studies were conducted earlier this year, and according to the scientists, these results are crucial for speeding up oil spill response and protecting freshwater resources. So why were dogs chosen instead of specialized equipment? Well, the scientists used that too. Over the years, they tried sonar, radar, fluorescence, optical sensors, and even old-fashioned labor-intensive drilling to search for oil spills. They even used human eyes and flashlights. But it turned out that the most sensitive scientific tools and manual methods couldn't match the 100% success rate of the dogs. Plus, the 4-legged oil detectors are fast. They can cover up to 4,300 square feet in 20 minutes. And they're relatively cheap to train. Lots of advantages. It's also worth mentioning the conditions under which people used to work on their own. Before the discovery of the dogs' new skills during oil spill response from offshore pipelines, rescue teams had to spend a lot of time figuring out exactly where the oil leak occurred before taking any cleanup action. And remember, we're talking about working in ice. That's extremely difficult for humans. Dogs, however, work quickly and accurately, and thanks to their fast spill detection, they can help reduce the impact of oil on freshwater ecosystems. According to the founder of Chiron K9 LLC, a leading dog training company, the secret to their effective work lies in their incredible sense of smell. Now, dogs aren't just used to detect illegal substances at airports or victims of earthquakes. They can also be utilized to enhance environmental protection. Sounds pretty cool. And who would turn down a fluffy helper?